Welcome to Resilient Robots, New Frontiers in Autonomous Intelligence. In this episode, we highlight 17 breakthrough research papers in robotics from June 26, 2025, focusing on intelligence, adaptability, and collaboration. Join us as we explore the latest innovations in perception, planning, and learning, and take a journey into the future of robotics. This presentation will navigate the robotics revolution by unpacking dominant trends shaping the field today. Key research themes include learning, perception, and human-robot interaction. We will spotlight 3 seminal papers that are driving the discipline forward, synthesize critical findings and methodologies, and discuss future directions alongside the open challenges that remain. Robotics is an interdisciplinary field blending mechanical engineering, artificial intelligence, computer science, and electronics. The central aim is to create machines capable of sensing, reasoning, and acting within their environment. Applications range from autonomous vehicles and drones to surgical robots and underwater explorers. Robots are rapidly evolving from mere tools to flexible collaborators, addressing complex, real-world challenges across diverse domains. The first major theme is intelligent control in dynamic environments. Robots must plan and adapt their actions when faced with unpredictable or even hostile settings. For instance, Smith and colleagues demonstrate off-road navigation using visual cues alone, while Chen and co-authors study risk-aware path planning for robots moving through crowded spaces. These scenarios require real-time decisions with incomplete information. Reinforcement learning is a foundational technique enabling such adaptive robotic behavior. Another dominant theme is the shift from rule-based systems to adaptive, data-driven and knowledge-based learning. Imitation learning with semantic generalization, as explored by Miao and colleagues, allows robots to learn efficiently from fewer demonstrations. Large language models, such as those investigated by Li and collaborators, are guiding robotic manipulation tasks. Patel and team demonstrate the integration of vision, language, and action, enabling robots to generalize skills in novel scenarios with minimal data. Robust perception and sensor fusion are critical for robots operating in challenging or degraded conditions. Nguyen and colleagues employ visual-to-thermal translation to enable navigation at night, while Garcia et al. Use vibration analysis to infer terrain roughness. The Curl SLAM system, developed by Zhang and Associates, compresses 3-dimensional maps for efficient storage and real-time use. Sensor fusion techniques combine data from diverse modalities, enhancing resilience and reliability in robotic perception. Human-robot interaction and teleoperation constitute another central theme. Improving remote collaboration between humans and robots is a focus, with Lim and colleagues demonstrating motion scaling for personalized telesurgery control. Kaur et al. Present multi-robot formations using only onboard sensing, eliminating the need for GPS. Open-source simulators, such as those developed by Wang and collaborators, enhance accessibility and reproducibility in robotics research. Across these studies, emphasis is placed on safety, adaptability, and collaborative efficiency. Key findings from these breakthrough studies are moving the field of robotics forward. Lim and colleagues show that teleoperation performance depends on personalized settings, improving safety and efficacy. Zhang et al. Achieve efficient 3-dimensional mapping with compact representations, enabling long-term robotic missions. Garcia's team demonstrates that Bayesian terrain analysis improves autonomous driving on challenging surfaces. Miao and Associates highlight that semantic knowledge significantly boosts data efficiency in robot learning, and Patel's unified vision language action models enable robots to tackle complex, multi-step tasks. The methodologies underlying these advancements are diverse and robust. Reinforcement and imitation learning serve as foundational approaches for skill acquisition. Bayesian inference methods manage uncertainty in real-world environments, while deep learning powers perception and integrates multimodal information. Planning is often addressed through model predictive control and path integral methods. Sensor fusion techniques, including Kalman filters, are employed to build robust state estimates, combining data from multiple sources to support reliable decision-making. The selected paper Curl SLAM, authored by Zhang and colleagues, introduces a paradigm shift in efficient 3-dimensional mapping for mobile robots. Utilizing spherical harmonics implicit encoding, Curl SLAM represents environments compactly, significantly reducing storage requirements while maintaining precision. The system operates in real time on standard CPUs and has been released as open-source software, facilitating long-duration, collaborative, and resource-constrained robotic missions. This work is recognized for both its technical novelty and wide applicability across robotic platforms. Another featured study, by Lim and co-authors, addresses the optimization of teleoperated surgical robotics. Their research highlights that the ideal motion scaling factor in telesurgery is user-specific and also depends on network delay. By modeling these relationships, the team enhances the safety and effectiveness of remote robotic operations. The findings have broad implications, impacting not only medical robotics but also industrial and hazardous environment teleoperation, and are selected for their contributions to safety and human-robot collaboration. A third highlighted paper, by Miao and collaborators, advances robot learning through the introduction of semantic keypoint graphs. This approach enables robots to understand object categories at a higher level, allowing manipulation skills to generalize with significantly fewer demonstrations. The methodology is robust to variations in object appearance and lighting, and matches or surpasses state-of-the-art performance. This paper is chosen for its impact on generalization and data efficiency in robotic imitation learning. Looking ahead, the field of robotics faces several critical challenges and promising directions. Achieving robust generalization in unstructured, real-world environments remains a top priority. Increasing data efficiency and reducing the need for extensive human supervision are ongoing goals. Researchers are also working to improve the interpretability and reliability of deep models, bridge the sim-to-real gap for deployment outside of simulation, and enhance resilience to faults and sensor failures, ensuring safe and reliable operation in critical applications. This synthesis and review were generated using GPT-4.1 by OpenAI, with text-to-speech and image tools from Google. Human experts reviewed the content for accuracy and clarity, and references are provided for all cited research papers. While every effort has been made to ensure completeness, some oversights may remain. The deck is designed to inform and inspire further exploration and engagement with the latest robotics research. Stay ahead in robotics and AI research with AI Frontiers. Subscribe to our YouTube channel for more deep dives, join the discussion, and share your thoughts. Your curiosity drives the next frontier. Thank you for exploring with us. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.